Good day, students. Welcome to ISIFE EDUBLOG. I am your uncle, Stephen Chooks, and today I'll be taking you on moment of a force in physics. Please, if you are new to this channel, please don't forget to subscribe, like, and share the videos with your friends. Today on moment of a force, we are going to start by introducing what moment of a force is. Number 2, we talk about the formula for moment of a force and solve some calculations there. Number 3, we talk about the principle of moments and the questions that comes with it. Number 4, we talk about the center of gravity, followed by measurement of mass of uniform bodies. And then we talk about the reactions on pivots. For more exercise, you can follow the link in the description box under this video for past questions on WAEC, JAMB, and post-UME. So, the first thing we are going to talk about is the introduction and the definition of moment. First of all, what is moment of a force? We say moment of a force can be defined as the turning effect of a force, which does not have an opposite and equal reaction. Like for example, if you are moving the knob of a tap, it is going either clockwise direction or anti-clockwise direction. There is no opposite force opposing it. Hence, for example, let's assume we have a meter rule and a pivot here, and we have only one force, F, about this turning point. The point of the pivot is called the turning point or the fulcrum. We know force, the unit of force is Newton, and let's take that it has a perpendicular distance from the turning point of D. Hence, this force is acting downwards on this meter rule at a distance of D from its turning point. Secondly, we talk about the formula for moment of a force. And what is the formula for moment of a force? The formula for moment of a force is given as the product of the force and its perpendicular distance from the turning point. First of all, the distance has to be perpendicular to the force, and the distance has to be taken from the force to the turning point. This is very, very important in solving calculations in moment. Hence, we say moment is equal to force multiplied by the perpendicular distance. What is the unit of moment? We can recall that the unit of force is Newton, and the unit of the distance, SI unit of the distance, is meter. Hence, we say that the unit of moment is Newton meter. That is Nm. That is how simple moment of a force is. When you are given the force and you're given the distance, and you're asked to find the moments of the force, you simply multiply the force and the perpendicular distance. But you have to make sure that the distance is in the SI unit, which is meter. Let us take a very quick question on it so that you can get exactly what we are talking about. Let's take that we have a meter rule and a pivot. I will have a force perpendicular to the meter rule, and maybe this is a force of 20 Newton, and the distance from the force to the pivot is 3 meters. And we are asked to calculate the moment of this force. We simply say that moment is equal to force times distance. Hence, the force is what? 20 Newton times the distance is what? 3. And we can now say 20 times 3 will give us 60. Hence, the moment of this force is 60 Newton meter. That is how simple it is. Most of the times, they won't ask us to find the moment. The moment can be given, and then maybe the force or the distance will be given. And they will ask us to find either the distance or the force. We simply make one of them the subject of the formula. For example, if we are given that moment is equal to 100 Newton meter, and maybe the force is equal to 5 Newton, and we are asked to find the distance, the perpendicular distance between the force and the turning point. We simply use the same formula by saying that moment is equal to force times distance. And the moment is already given as 100 Newton meter. It is equal to the force is 5 times the distance. Hence, we divide both sides by 5. When this 5 cancels this 5, we have the distance. 100 divided by 5 gives us what? 20 meters. That means that the distance between the force and the turning point is 20 meters. How about a situation whereby the force is not perpendicular to the fulcrum or to the turning point? There we have to first of all get the vertical component of the force before we solve it with whatever is given for us to solve. Let me give you an example. Okay, in this particular question, we are given that the distance is 5 meter, and the force is 20 Newton. But the only difference here is that this force is not perpendicular to the distance or to the body. It is inclined at an angle to the horizontal, and the angle is 30 degrees. Before we solve this, you have to first of all get what is called the vertical component, because in force, we have vertical component of a force and we have horizontal component of a force. But what do we need to solve this moment? We know that the force has to be perpendicular to the distance, and hence, the force that is perpendicular to the distance is the vertical component of this force. Hence, we have to find whatever is going to be here using 20 and 30. For vertical component, if this is a right angle triangle, this force given is the hypotenuse, H. And we are looking for the opposite. We are looking for the opposite. The vertical component is the opposite of this right angle triangle. Hence, we are looking for the opposite, and the 20 Newton is the hypotenuse. Hence, from SOHCAHTOA, we can see that we are going to make use of this, which means we are using sine. Hence, if we call this f of y, because vertical component is f of y, while horizontal component is f of x, we say that this point is f of y, opposite is f of y, hypotenuse is 20. But from SOHCAHTOA, it is going to give us sine of the angle, which is sine 30, is equal to opposite over hypotenuse. And opposite is f of y, which we are looking for, all over hypotenuse, which is what? 20. If we cross multiply, f of y times 1 will give us f of y equals to 20 times sine 30. Hence, we have 20 sine 30. And when you use your calculator, you are going to see that when you press 20 sine 30, it is going to give us 10, because sine 30 is 1 over 2. So 1 over 2 times 20 is going to give us 10 Newton. Now, we have gotten that the horizontal component, the vertical component of this force, which we need, is 10 Newton. We are no more making use of 20. We now start with what we know again, that moment is equals to force times distance. Hence, we are using the vertical component, which is going to give us 10 times the distance is what? 5. And the moment of this particular force is 50 Newton meter. That is when you are given a force inclined at an angle. Next thing we are going to talk about is the principle of moment. which is one of the important topics, one of the important subtopics in moment.